Hello, and thank you for clicking on our video. My name is Ryan Baldwin. I work in the Business Development Department, and I will be discussing a few slides before my colleague Dimitri walks through a use case demonstration of our recently released Change Data Capture component, the InfoCDC. The goal for today's demonstration is to automatically integrate IBMI order information to SQL by leveraging InfoCDC and the AS400 gateway for Kafka. In case you are not familiar with InfoView Systems Inc., our company was founded in 1994 and has grown into an international team of cross-platform professionals. We have developed a focus on system integration and legacy modernization for a variety of verticals such as healthcare, financial, manufacturing, and distribution. InfoView also has a complementary product suite that focuses on connector-based products for the IBMI AS400. The AS400 gateway for Kafka is composed of three connectors with source and sync capabilities that have been officially tested and certified by the Confluent team. The AS400 gateway for Kafka enables companies leveraging IBMI to integrate with Kafka without the need to implement and operate additional middleware solutions. The connector calls IBMI programs directly from Kafka and passes the response to another Kafka topic in near real time via native data queues. As for InfoCDC, it is an intuitive, lightweight change data capture solution that provides core data integration capabilities at a fraction of the cost of competitors. Developed solely in-house by InfoView, it's designed to work alongside a listener, in this case the AS400 gateway for Kafka. The component then listens for database changes and streams them to their final destination in near real time, enabling complete integration solutions with zero coding required. The addition of InfoCDC alongside the AS400 gateway for Kafka unlocks a new level of integration capabilities for teams leveraging the IBMI. In this demonstration, new orders will be created in the master IBMI DB2 table, where each order will be given an order name and quantity. Once each order is created, the InfoCDC will pick up the new orders and stream them into a data queue, which will then transfer them to the Kafka source connector. After being processed by Kafka, the sync connector will stream them to their final destination, which in this scenario will be MySQL tables. Next, I'll be passing it on to Dimitri, who will be starting the demo portion of this video.
Thanks, Ryan. In this demo, guys, we are going to show how using InfoCDC product and Kafka Connect configuration, we can define our data replication pipeline without any coding required, just the configuration. So this is a simplified use case, of course, but it's fairly representative of what many of our customers are trying to achieve, where the core system of record application running on IBMI system needs to replicate some data in real time, whether for analytics or to offload some read-only transactions from their backend systems to intermediate cloud-based databases, or just to notify other systems of change events. So in this case, for example, we want to capture the changes to our order management system and stream them in real time to MySQL database running on AWS platform. So first, let me walk through the screen. This is our dummy ERP system or order management system. As you can see, for this customer, we have 6 orders already created, which matches the orders in our MySQL for that same table. And as you can see that the latest order is 15110, and that matches what we have in our ERP. So let's go ahead and create a new order. And, so we're going to press F10 to create a new order, and that should result in new order details immediately visible in our cloud database. F10, and then rerunning this query. As you can see that there is another record created, 15111, and that's exactly the order number that we just created. So it worked great. Now let's test the order status update. And actually, before doing that, let me jump into InfoCDC configuration and show how the change data capture is defined on IBM end. So this is the configuration view of InfoCDC product. And don't be scared by too many tables or busy view. It's just something that we used for our internal testing. But for this demo, there are 3 relevant tables that we defined in this product. It's order header, details, and customer master. So for example, for order header, into detailed configuration. And here, as you can see, we capture the insert, update, and delete events. The product allows you to select all 3 or just a subset of events. It will automatically sense the structure of the columns and bring in the types, lengths, and sequence of the columns, as well as the unique keys identified within DB2 database. And here you can choose to replicate all columns and select all kinds of changes, or just filter on specific columns. This would be very useful for customers running on older systems that were designed quite some time ago, where designers tend to favor the denormalized data models, where, for example, the same customer table might have information about customer, account balances, customer biographical information, everything on a single line, resulting in a huge, very long record format. So if, for example, CRM system only is interested in customer name and address changes and doesn't care about any financial information, you could only select a subset of fields to watch for and replicate. So that could greatly reduce the number of chatter between your IBM system and external systems. So let's take a look at the change event. Back to our order management system. Let's change the order status from booked to, say, picked. Press enter. Rerun the selection here. And as you can see, the record for 15111 now shows order status of picked. So it worked. Magic. Fantastic. Demos are not always that lucky. So that is the IBMI side. As you can see, it's fairly straightforward. You just define your conditions. You define the table, columns, which columns we need to listen for changes for, and which columns do we need to send out for replication. And that's pretty much it. The product automatically creates a data queue where the change will be streamed to, as well as the format file that represents the structure of that message, includes the columns we need and some additional metadata. Now, switching over to InfoCDC, Kafka Connect configuration for this. Again, Kafka demo that we created is probably a simplified approach where we just have standard Kafka topics and 2 sets of connectors. Number of sources that listen for data queue messages, and then sync connectors that apply those changes to target database. So if we take one of the source configurations, go through this. We point to our IBMI environment. We provide user ID and password. It's all can be parameterized, of course. The connector does support TLS configuration, where you can define your certificates in trust store and reference in the connector. It supports both keyed and non-keyed data queues and provides some other controls over timeouts, reconnections, and other behavior of the connector. It does require a license, and you can define license location either on each local environment or somewhere in the shared network or cloud storage. And then the main thing here is to point to the actual data queue to listen to, specify the format file that gives this message a structure and types, and provide a target Kafka topic where that message should be placed. And that's pretty much it. So that's a very simple configuration for the data queue source. Basically, you just point Kafka Connect to continuously listen for new changes. And the moment the message is placed on data queue from IBMI side, it will immediately be pushed to Kafka topic. And then obviously, there are many different things that can be done with that message. In this case, we can configure a very simple JDBC sync connector that pulls the data from this topic and connects to this RDS instance of MySQL. We do implement upsert here, so for new records, they will be inserted. And if the record already exists based on the key, it will just be updated with the information. And here's the target table name. So simple configuration, both for source and sync, and in a few minutes or hours, maybe with testing, you're getting an end-to-end replication solution that works without a single line of code. Back to you, Ryan.
Thank you, Dimitri, for the demonstration. As the InfoCDC does require a listener to work, it's an ideal add-on for companies leveraging Kafka and the IBMI. Due to its unique ability to add codeless near real-time integration at a fraction of the cost of competitors, it does open the door to lots of new opportunities. For teams interested in evaluating InfoCDC, we do offer 4 different types of POC models. Self-service allows your company to spend 30 days evaluating the product completely in-house. And if you have any questions or issues, our product and integration engineers can assist as needed. Allocated consultant revolves around InfoView providing a consultant for a short period of time to review the POC and assist involved project team members. For the sandbox method, the InfoView team will recreate the desired use case with our own sandbox environment. Lastly, Rapid Start entails our team taking ownership of product configuration, implementation, and related integrations within an organization's best practice. The result will be a solid launch point for future IBMI integration projects. In addition to InfoCDC and the AS400 gateway for Kafka, our team also developed additional products with the goal of converting the 4 primary use cases of integration, data streaming, robotic process automation, and change data capture. The AS400 gateway for MuleSoft is a certified MuleSoft plugin that eliminates the stress and impact of legacy system integration on development teams, allowing users to connect their IBMI AS400 directly to the MuleSoft Anypoint platform. The AS400 gateway for AWS is an Amazon machine image that provides generic REST API integration for IBMI operations. The AS400 RPA is an open source IBMI green screen automation plugin, enabling users to simulate user actions without the need for endpoint application source code. The connector works directly with MuleSoft and Kafka app and does not require any additional infrastructure or components installed on the IBMI. Thank you for your time watching this demonstration. If you have any questions or would like to get in contact, our phone number and email are on the screen. You can visit our website at www.infoviewsystems.com or check our information in the description below.